Hi everyone, welcome to our next video for week 5. We're going to be discussing hypothesis tests for two means where the population standard deviations are known. Before I pull up that next slide, we do know a few things. We know when we're doing confidence intervals or tests for means, it's either a z-test or a t-test, standard, normal, or student t. And I know if I know my population standard deviations, we're going to use the standard normal. So this is going to be a z-test. Our critical value is going to look exactly the same. You're going to find that based on your level of significance, your alpha value. You're going to look it up in table E or pull up inverse norm or inverse normal. And then we get down to that test value and it looks kind of scary. And if you like doing the traditional method and you like doing things by hand, there is an important thing to know. In most word problems, they're going to give you two sample means. They're not going to give you two population. And the reason they do that is when we write our hypotheses, remember that we're assuming our null is an equality. And instead of mu equals a number, which is what we were doing with a single mean, we're now comparing the means from two populations. So our null assumption is that the mean for the first group equals the mean for the second. And then our alternative will be an inequality of some kind. So a not equals, a less than, or a greater than. Because our null is assuming that the means are equal, unless we are told otherwise in the word problem, mu1 minus mu2, if mu1 and mu2 are the same number, subtracting is going to give me 0. So this whole part of that formula is usually something you don't have to worry about. I'm assuming most of you are doing this with a calculator because it's 2023 and humans are lazy, including myself. So for the calculator, you can get that test value by using the same function calls we're going to use in the p-value method. So on a TI-84, same menu, stats test, and then you're looking for option 3, which is two sample z-test. Or in GeoGebra, it's z mean 2 test. In the TI-84, it should prompt you for that information you're looking for. If you're in GeoGebra, it wants the information for population 1 first. So sample mean, population standard deviation, sample size. And then it wants that same information for group 2, and then the tail. You'll notice we've got x1, x2, u1, u2, sigma 1, sigma 2. These labels, it doesn't really matter which one you call 1 or 2, as long as you're consistent throughout the entire problem and that you make sure the symbol in the alternative statement matches the relationship between those two groups. We're going to work through 3 examples in detail so you can see how this works, because this is just a little bit more complicated than the examples we did with 1. So let's go ahead and work through example 1. It says a study using 2 random samples of 35 each found that the average amount of time those in the age group of 26 to 35 spend per week on leisure activities was 39.6 hours. And those in the age group of 46 to 55 spend 35.4 hours. Assume the population standard deviation for the first age group is 6.3 hours, and the population standard deviation of the second age group is 5.8 hours. At alpha equals 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? Ooh, lots of words. Let's not panic. We're going to go down and look at that last statement because that's usually where the information about what this problem is about is located. says, can it be concluded that there is a significant difference? We recognize that wording. Can it be concluded is asking us to test a claim. Specifically, we're testing a claim that there is a significant difference between the two groups. And we know that keyword difference means the alternative statement is going to be a not equal to statement. So we're going to go through the word problem, pick off what we're given. Says 2 random samples of 35 each. So random samples are the same size. And then we have 2 groups. We have the 26 to 35 group, and their sample mean was 39.6 hours. And then we have the 46 to 55 group with a sample mean of 35.4. They then go back and give us population standard deviation. So population standard deviation for the first age group is 6.3. So that's a sigma. And then for the second group, it says population standard deviation is 5.8. You'll notice here for group 1, I'm using orange. For group 2, I'm using green. So color coding is going to be really helpful here. Not mandatory, but it might be helpful. But I'm also going to do something else here. I'm going to take that information and I'm going to make a table. So I'm going to organize all that information that I was given. So I was given information about sample size, sample mean, and population standard deviation. And I was given that for 2 groups, 26 to 35 years old, and I'm going to call that my group 1, and then 46 to 55. I'm going to call that group 2. All we're going to do is in this table, we're going to record those values from the problem so that it's easier to keep track of what we're doing when we run our calculator test. So we know both sample sizes are 35. We know group 1, the 26 to 35 is what I marked in orange. So 39.6 as the mean and 6.3 as the population standard deviation. And then my group 2, 46 to 55 is in green. So 35.4 with a standard deviation of 5.8. Because they use that keyword population standard deviation, because we have this guy here, we know that this is a z-test. So we are running a z-test for 2 means. I'm going to go ahead and use the p-value method. Starts the same as the traditional. We're going to identify our hypotheses. We're then going to run that test to find the p-val. We're going to make our decision and then summarize our result. So for our hypotheses, we're comparing groups 1 and group 2. So mu1, 2. We know in that last sentence, it said, can it be concluded that there is a significant difference? So our alternative is a not equal to, and that's the claim we're testing. And then by default, the null is an equal sign. So for p-value, we're going to pop up our calculator. I'm going to do this first example with a TI. So stats, tests, option 3, 2 samples of the test. And then it's going to ask us for some information. So I'm going to go ahead and write this down. Oops, so that we can show our work on our paper. So 2 samp the test, that's the name of the function. And then it's asking for sigma 1, 6.3, sigma 2 is 5.8. X bar 1 is 39.6, and N1 is 35. X2 is 35.4, and N2 is 35. I believe the last prompt is going to ask us for our tail. You'll notice that having that information organized in a table makes it easier to pull into this function because 2 sample tests are going to require more information. So let's go ahead and type all of that into our calculator really quick and then get our test value. Okay, so when we press calculate, we get those 3 familiar values. We get our alternative statement, we get our z-score, and then we get our p-value. So the p-value here is 0.0037. And that's pretty tiny. That's less than 1%. We're going to go ahead and compare that to our alpha value. And they did give us an alpha. They said alpha was 0.05. So we're comparing our p-val to 0.05, and our p-value is definitely less than 0.05. So we meet that less than or equal to requirement to reject. So we are rejecting our null hypothesis. We are statistically confident that there is likely a significant difference here. So we're going to go ahead and summarize that in our sentence. And we start the same way we did for one sample test. We look at our decision in step 3, we rejected. So there is evidence. And then we look at our hypotheses, and the alternative is the claim. So we're talking about supporting. There is enough evidence to support the claim that, and then we pull wording from the problem, that there is a significant, if I can spell significant, I hate the English language, difference in the average times each group spends on leisure activities. So again, is enough or is not enough, that's coming from step 3. Support or reject is coming from step 1. And then the actual claim is coming from the words in the problem. And I just pulled that from that very last statement in our word problem. Can it be concluded that there is a significant difference? Okay, let's try another one. This time I'm going to use GeoGebra so we can see how both methods work. So example 2, at age 9, the average weight, 21.3 kilograms, and the average height, 124.5 centimeters, for both boys and girls are exactly the same. A random sample of 9-year-olds yielded these results. At alpha equals 0.05, do the data support the given claim that there is a difference in height? Notice that this word problem did something nice. Instead of throwing all of that information at us in the word problem itself, they took that information out and organized it in a table for us. So we don't have to go through and construct that table. It's been done for us. We know we have our values for n, our values for x bar, and then they use an interesting word here, population variance. The variance is the standard deviation squared. So this row here is not sigma, it's sigma squared. What that means is when I go to plug this into my calculator, I want to use the square root of that number. I'm not going to play that trick on you on your test this week, and I don't think you're going to see that in your homework, but just in case you encounter that, if you're given variance and you want standard deviation, take a square root. So let's pick through the problem. Do the data support the given claim? So we know we're definitely doing hypothesis test. It says that there is a difference in height. So that's a not equal to for our alternative. And they give us our alpha is 0.05. And everything else has been labeled for us. The only thing we have to decide is group 1 and group 2. I just tend to do first column as 1, second column is 2. It doesn't really matter for difference. It will matter when you're talking about less than or greater than. So let's go ahead and set up our test. We're doing a z-test for 2. And in this case, I very clearly know it's a test for me. We know that it's a z-test because we're given information about the spread for the population. Bear with me here. I'm going to set up our frame for the solution. So starting with the null and alternative hypotheses, these are claims about 2 mean. We know the claim we're testing is that there is a difference in height. So the alternative is a not equal to, and that's the claim of interest. And then the null we can always default to equal to. Next step, we're going to go ahead and run this test in a calculator. Sorry, I just had a brain fart. So let me go ahead and pull up. In this case, we're going to run GeoGebra. Assuming I can find that window on my computer. So here is GeoGebra. And we know that we're doing a z-mean2 test. Let's see if it tells us what it needs. So sample mean, sample standard deviation, sample size. So X bar, sigma, n, and then the same thing for group 2. And then I'm pretty sure it wants the tail. If you can get this to scroll sideways, we will take a look. Come on. Nope, not going to cooperate. Still not. Yeah, tail. There we go. Okay. So let's go ahead and run that. I'm going to scoot this way so we can see that sample information. So z-mean2 test, and we want, oh my gosh, I've already forgotten. What do we want first? Oh my gosh, Andrew, you have a brain fart today. Mean standard deviation sample size. Mean standard deviation sample size. I can remember that. Mean standard deviation. So the mean for the first group, 123.5. Standard deviation is the square root of 98. And then our sample size is 60 for group 1. And then same thing for group 2. So 126.2, the square root of 120. And a sample size of 50. And then we feed it our tail, which is a not equal to. So that is over here. We press enter. Scoot this back over here. We can see that this gives us the p-value first. Sorry, technical difficulties. So our p-value is 0.1788, which is a pretty big p-value. And I should write down the test that I just ran. So showing my work on my homework or my test would mean copying down what's in that window. So z-mean2 test, and then the values that I plugged in, 23.5, square root of 98, 60, and so on. So it is important that while you're running this on your homework, that this is what you're writing down on your paper to show work. I know for several of you, I've made comments that we're not showing the calculator work. That is important. If you were taking this as a AP stats in high school, the AP board's even more picky in that they expect you to go through and then label what each of these is. So it could be worse. I just want to see those numbers and what you plugged in, because I will know what order you need it. Okay, so let's get rid of the GeoGebra window that's clogging up our screen and move on to step 3, where we make our decision. So we're comparing our p-value to our alpha of 0.05. I can see that 0.1788 is bigger than 0.05. So this is a do not reject statement. So our last step, we just need to interpret that in terms of the word problem itself. So we look in 3 places. The first place is we look to that step 3 decision. We did not reject, so there is not enough evidence. And then we go look at our claim. Our claim is the alternative in step 1. So we're talking about support. There is not enough evidence to support the claim that. And then we look at the claim and it says, do the data support the given claim that there is a difference in the mean heights for 9-year-old girls and boys. Okay, so before I move on to example 3, a couple of discussions. In the last video, we talked about incarceration for drug offenses. We talked about obesity. In a lot of these, you're going to see comparisons between genders, and they're going to assume both boys and girls. We know for all of these things that we're talking about in stats that the real life human experience is more varied than just 2 categories. So keep in mind, as a researcher, it's kind of up to you to make sure that your studies are accurately reflecting the population that you're describing or that you're interested in. We see a lot of issues in statistics, particularly older statistics, where the researchers were wealthy white men who were attending Ivy League colleges. And so a lot of older stats data comes from the communities around those Ivy League institutions, which were primarily white and wealthy. And that's going to affect the type of data that you see and the decisions you can possibly draw from it. So keep in mind, this Intro to Statistics book is an oversimplification of what the word really looks like in order to aid us in using simple examples. As a researcher, it's really important that you look at the actual complexity of your system and don't oversimplify. Otherwise, you're not going to get results that are representative. I also want to say that so that no one feels excluded. Stats is for everyone. And again, we're just doing an oversimplification here so that the problems are not scary. But we know as scientists that the world is more complex than 2 boxes. Yeah. Okay, get off my soapbox here. Let's clear that. I'm going to go ahead and work through example 3. I'm going to encourage you to pause your video now and check back in a second to see how your answer compares to mine. Okay, for example 3, it says teachers' salaries in New York and Massachusetts lead the list of average teacher salaries. The New York average is $91,097, while teachers in Massachusetts make an average annual salary of $89,530. Random samples of 45 teachers from each state yielded the data below. At alpha equals 0.1, is there a difference in the means of the salaries? So we can see the sample means are the values from the problems. We can see that they gave us a population standard deviation. In the word problem itself, they gave us 3 important pieces of information. Samples of 45 from each state. So N1 and N2 are both 45. We're using a level of significance of 0.1 or 10%. And our alternative should be a not equal to. Is there a difference? I know that this is a z-test for 2 means because in the table, I'm given sample mean, and I'm also given population standard deviation, which makes it a z-test. You can see my alternative statement in step 1 is the not equal to, and that's the claim we're testing. My null is that default equal sign. For step 2, I did this one on the TI-84, so 2 samples z-test. And I entered the values in the order that you see on the screen. So population standard deviation 1, 2, sample mean 1, sample size 1, sample mean 2, sample size 2, and then your tail. When I did that, I got a p-value of 0.3554, which is really big. It's like 35.5%. So what that means is these samples are not different enough that I can assume they came from populations with different means. So looking at that p-value compared to alpha, the p-value is clearly bigger than that level of significance of 10%. So we're going to fail to reject the null. When we form our conclusion, that means there's not enough evidence to support our claim that there's a difference in the mean salaries of teachers in New York and Massachusetts. Okay. By the way, if you're interested in becoming a teacher, those mean salaries are from 2023. Those are current, and they are still the top 2. New York is the top payer. Massachusetts is the second top payer. New York is the top payer because they require their teachers, at least for secondary school, to have a master's. That also puts into perspective where we rank as California teachers, because California is one of the most expensive states to live in, and we are not in the top in terms of how we pay our teachers. So I'm not telling you don't become a teacher. I'm a teacher. I teach high school during the school year. It's just, yeah, make sure you're getting into it because you love teaching and you're not expecting to become a millionaire, because that's not what teaching does. Okay. Sorry for the side tangent. If you have questions on what you saw in the video, you know where my contact info is. I'm available Tuesday, Thursday, Saturday for office hours. Otherwise, I will see you in our next video.